So China is selling this micro EV for under $3,000. And it led me to ask two questions. Number one, why are we paying so much money for our Teslas? And number two, how do I build something like this for myself? So in this video, I am going to break down what it takes to build yourself a fully electric autonomous vehicle from scratch all by yourself. And spoiler alert, it is not going to cost under $3,000. A huge challenge that comes with selling vehicles in the US is that you have to clear FMVSS and DOT regulations. You have to do extensive crash testing to prove that your vehicle is in fact going to be safe to drive at high speeds on the road. So we're going to circumvent a lot of those costs and a lot of those requirements by building ourselves a road-legal, low-speed vehicle. And we're going to be doing it in 4 stages. First of all, we're going to be building the chassis and body. Then we're going to be building the drivetrain and the battery pack. Then we're going to be building the by-wire controls, which is basically the hookup the car needs in order for it to be self-driving. And finally, number 4, we are going to be installing the self-driving kit. Okay, let's get into it. Stage 1, we're going to be building the chassis and the body. And our journey is going to begin at the junkyard, where we're going to be finding a golf cart and we're going to be stealing the rolling chassis platform from this golf cart. Now, a lot of you are going to say that this is cheating. This is cutting corners. And it is, but let me explain why I'm doing it. A chassis includes the wheels, the frame, the steering column, and even the brake setup, all of which is pretty simple to manufacture, but it is difficult to prototype. So unless you have a personal relationship with a machine shop and a personal relationship with parts suppliers, it is going to be very expensive for you to prototype a rolling chassis. But big companies that have those relationships are able to manufacture it for really cheap, and we're going to lean on their expertise a little bit. And while we're at the junkyard, we're also going to find for ourselves 4 sets of seats with seat belts, because those things are also easy to manufacture and difficult to prototype. And they don't really constitute the engineering challenge that we're really excited to take on for this project anyway. We're still going to have to create the body for this car, and we're going to be using fiberglass or ABS to create the body panels for the car. Now that we have a rolling base, let's get into the second stage, which involves the fun engineering that we're really trying to get into, aka setting up a battery-powered drivetrain. We're going to start off by finding a 10 kilowatt-hour battery that comes with a battery management system, or a BMS. The BMS arguably is going to be the most important safety feature in our car. The BMS is responsible for reporting the health of the battery, and it's responsible for making sure that no one cell in the battery is getting overworked, because that could lead to a fire. And the last thing we would want is for our prototype vehicle to spontaneously combust during training. Then we're going to be finding a motor that is capable of delivering 25 kilowatts of peak power, and we're going to be coupling that to a controller. The controller is going to be responsible for taking electrical signals, for example, from the throttle when you press the accelerator pedal, and determining how much of a current should be drawn from the battery in order to get the output that you need from the motors. And lastly, we're also going to be needing an inverter, because current from the battery is going to be a DC current, but motors need an AC current in order to operate, and the inverter is going to do that conversion for us. And needless to say, we're also going to have an onboard charger, because we don't just want to drive this car once until the battery drains out and then throw it away. This is a big investment. Okay, that was a fun bit of engineering. Now let's get into the next stage, which is setting up the by-wire controls, or the hookup needed for the self-driving assembly. Self-driving vehicles need to have what is called a controller area network, or CAN. The CAN is basically a communication network in which everything that needs to be controlled electronically by the self-driving system of the car exists as a node. For example, the steering column is a node, and how much torque will need to be delivered to it via the electric power steering system is going to be information that is channeled via the CAN. Other nodes are the brakes, which interface with the CAN using the electric brake booster, and the motor, which interfaces with the CAN via the throttle by wire system. Once we have set up the wiring for the CAN, we are now ready to allow a computer to take control of the steering, the throttle, and the brakes. Which takes us to module number 4, installing the self-driving kit. For the onboard computer, we're going to be using the Jetson Orin Nano, which is a fantastic choice because it is excellent at computer vision related tasks. We're going to be installing cameras in the front of the car and in the rear of the car so that the car has a continuous video feed of what's in front of it and what's behind it. We're going to be installing a GPS module so that the car is able to tell where it is in space at any given time. And we're going to be installing an inertial monitoring unit, which comes with an accelerometer and a gyroscope so that the car knows its exact orientation, how fast it's going or slowing down at any given time. Now, all of this is still hardware. The software that we're going to be using to allow our vehicle to be autonomously driven is going to be an open source one, and we're going to be relying on OpenPilot and AutoWare to do this. Now, obviously, this is still a very high-level plan, but these steps are everything that you need to do if you want to create a low-speed vehicle that you can title and register and drive legally on the roads of the United States of America. And obviously, this is more than 3 times the cost of whatever that microelectric vehicle that China was selling for, but this is still a prototype. If we are able to manufacture this, we are going to be enjoying economies of scale, and I am certain that we can drive down the cost significantly lower. While a vehicle like this may not be the most exciting thing to put out onto the roads of the US, I can't help but think that if a vehicle like this, that was fuel efficient and autonomously driven, could be put out into the roads of super populated and densely packed cities around developing nations, it could be a fantastic way to not just get around stop and go traffic in order to get to places, but also get a ton of very valuable self-driving data that could be used to train much more capable cars that could eventually replace these smaller, more fuel-efficient cars. Anyway, thanks for watching. Let me know in the comments if you want me to break down how to build anything else, and I will see you in the next video. Peace.